Okay, everybody, this is the practice test to chapter 3. I'm working out the solutions, and this is the best. This is the best thing for you to practice and be sure that you have mastered for your test. This is some great questions and a great way for you to study. So I'm going to start with number one. Number one, write the equation in standard form for the parabola with the given characteristics. Now, this curriculum is using standard form and vertex form as the same. So I will be sure to write standard/vertex on the test, but what they are talking about with this terminology is a times x minus h squared plus k. Okay, that's the format that we're looking for in this situation. So I says our vertex is -6, 3. Our graph opens down, and we have a stretched vertically factor of 5. So the -6 and 3, that represents our h and our k. Okay. So this is going to be our h and our k. Upside down means we're going to have a negative in front of our a value. And the 5 is our a value. So -5 is actually what our a value is. The stretched vertically by a factor of 5 is where we get the 5 from. The negative is because our problem says it opens downward. So our answer to this is f of x equals -5. And we have x minus -6. So you want to be careful with that because it's minus a minus. And so that's going to turn into a plus. And then we have plus 3. And I forget that squared a lot, but we do have that squared right there. So I'm going to rewrite this as f of x equals -5, x plus 6 squared plus 3. And that is our final answer for number 1, 1. Okay, number 1, 1. Okay, now I'm going to go to number 1, 2. So I'm going to erase this so that we can go back and look at number 2. And number 2 reads, or this is part 1, number 2, if that is more helpful for you to think about. So I'm going to do the I right here. So our vertex for this one is 5, -2. This parabola opens up, and we are shrunk vertically by a factor of 1/3. Okay, so the 1/3 is our a value. Our vertex is our h and our k. And our a value is going to be positive this time because we open up. So our answer to this is 5, or f of x equals 1/3 x minus 5 minus 2. Okay? F of x equals 1/3 x minus 5 squared minus 2. And this right here is our final answer for that one. Okay, now we are going to move on to number 2. The directions for number 2 say, put the given formula for the parabola in standard form. And again, this book is using standard form. F of x equals a times x minus h squared plus k. That also can be referred to as the vertex form. Okay, and so that's the form that we're getting it into. So what we have to do with that, we have to separate our function. So I have x squared minus 12x. That's what I'm going to do with to get my x value of my vertex. And I'm going to move my plus 33 over here. Now, for this particular problem, we do not have an a factor that we have to pull out. And so this is a good one to start with. So I am going to put this around parentheses. So what we are going to do now is we are going to complete this square. So we are going to take half of -12 which is negative 6. So I'm taking half of this value right here. So that's negative 6, and I'm going to square negative 6. So I am adding 36 inside these parentheses. So I got 36 by taking half of negative 12, which is negative 6, and then I squared it. And when I squared it, I got 36. Now, I have to keep this balanced, and I am working on the same side of this equation right here. I'm not adding anything to the f of x side. I am just working on this one side right here. Because I added 36 inside the parentheses, I need to subtract 36 on the outside of that parentheses. Okay? So if I add 36 and subtract 36 on the same side of the equation, then I am okay. So I have kept it balanced. Now what I'm going to do is I am going to factor this trinomial right here. I'm going to factor that trinomial. So I have f of x equals x minus 6 squared. Okay, and you'll notice that this value right here is always half of the b value, the negative 12. It's always half of that. And you could always FOIL that out to determine if we factored correctly. So that is, FOILing is an option there. Then I have 33 minus 36, and that gives me minus 3. So my vertex here, my vertex is 6, negative 3. My a value, or my stretch and shrink factor, is positive 1. So there's just a 1 right here. You don't have to write that 1 down, but that's what's right there. So you could put the value of 1, or you could write no stretch or shrink factor. Either one of those is acceptable. Okay? This opens upward because our a value is positive. Okay? So that 1 is positive. That means it opens upward, and so it's going to look like this right here. So now we are going to sketch the graph. We're going to sketch our graph. So our vertex is positive 6, negative 3. So it's going to be about right here. And it's going up. So it's going to look something similar to this. Now, if you remember on your quiz, you were also asked to identify the where it crosses the x-axis. So that is something that you would want to be able to identify. In order to do that, you would have to go back to our original problem up here, the x squared minus 12x plus 33. 33 can only be factored into 3 and 11, so you would have to use the quadratic formula or completing the square on this one. And that would be okay, and that would work, and you would be able to get a solution. So the question on our practice test does not ask us to identify the x-intercepts, but just be prepared that that's something that you might have to do. Okay, let's move on to the second one. The second one is f of x equals x squared plus 3x plus 1. Okay, and we are trying to get it into f of x equals a times x minus h squared. Sorry, I keep doing that. Plus k. Oh, yeah, plus k. Okay. So the first thing we're going to do is see if we can separate it a little bit. So I have f of x equals x squared plus 3x. And we're going to kind of put our plus 1 a little further away. Okay, so I am going to separate this right here. There's nothing that I pull out of the x squared and the 3x, okay? There's no stretching or shrinking factor or negative that I need to pull out. But I do need to complete the square on this. So this one is more challenging because I have a 3 right there. So half of 3 is 3 over 2. Half of 3 is 3 over 2, or 1.5. You're going to be better off if you leave it as 3 over 2. Okay? So now I'm going to take my 3 over 2 and I'm going to square it. When I square that, it becomes 9 over 4. So I am adding 9 over 4 right here. If I add 9 over 4 on the inside of the parenthesis, I need to add negative, and let me do that in a different color just so we can keep it all straight. Okay. So I am adding 9 over 4 here. That's what I'm adding on the inside of that parentheses. So if I add it there, I need to subtract it here. Okay? So now I factor. And if you remember, when I factor, this is a perfect square trinomial, this 3 over 2 right here, that's what I've got x plus 3 over 2 squared. That's where I get that from. Okay? Then I'm doing some fractions over here. So I have 1 minus 9 over 4. I have to change my 1, that's 1 over 1. I have to change my 1 over 1 to 4 over 4. I haven't changed the value of that. I've just made a common denominator. 4 over 4 minus 9 over 4 is going to be negative 5 over 4. Okay, so now we have our quadratic in vertex or standard form. So what I'm going to do now, my vertex is negative 3 over 2, negative 5 over 4. Okay. My stretching and shrinking factor, you can either say that it's 1 or you can say no stretching or shrinking. This does open upwards because my x squared is positive, and there's the a that we would be talking about is positive 1. So that's why it would open upwards. When we graph this, we are looking for our vertex. Our vertex is going to go negative 1.5. So I am going to go negative 1.5 and then down negative 1 1/4. So my vertex is going to be approximately right here. Okay, so it's in between negative 1 and negative 2. Then it's just a little bit further down than negative 1. Okay, now from our original vertex, we can tell, or our original problem, we can tell that I crossed the y-axis at positive 1. That's one of the things that we sometimes identify is where I cross the y-axis, and that's because if I plug 0 in for both my x's, I'm left with positive 1. I'm opening up. We were not asked to identify my x-intercepts, but we could if we needed to. We would have to use the quadratic formula on this one as well. Okay, let's do the last one. So our next one is f of x equals 4x squared plus 24x plus 41. So this one is going to have an extremely high y-intercept. And here's our y-intercept right here. It's 41. We aren't going to worry about that. We're going to go ahead and graph it and put it in standard form. This particular one right here, we do have a stretching and shrinking factor. And so we've got to factor out that 4 in our first 2. Now we only factor it out of the x squared and the x. So I've got 4 times x squared plus 6x. So I factored that 4 out, and then I leave my plus 41. Now this sometimes confuses students, so let's talk about exactly what we have to do. You are still going to look at your 6, and you are going to determine what half of that is. So half of 6 is 3. Okay, half of 6 is 3. So you can write that down over here if you need to, because you will use that again. 3 squared is 9. So we are adding plus 9 inside the parentheses. So because we're adding plus 9 inside, we're going to have to subtract something on the outside. Now, what you need to realize is that that 9 is being multiplied by a 4. So we're not just adding plus 9 to this entire equation. We are actually adding 9 times 4 to this entire function. So 9 times 4 is 36. So since I added 9 inside this parentheses, I've got to do the opposite of 9 times 4 on the outside. So that gives me negative 36. Okay, so sometimes students get a little bit confused because we've got that factor on the outside that we have to deal with. Okay, so now we're going to keep our f of x. Okay, our 4 is our stretching and shrinking factor. I factor x squared plus 6x plus 9. That's a perfect square trinomial. And that's squared, and then I'm left with plus 5. Okay, so my vertex here is negative 3, positive 5. That's my vertex. I am stretching by a factor of 4. So my A value here is 4. It is still going upward because my A value is positive. That's why it opens upward. And let's graph it. So I have negative 3, positive 5, okay, so it's going to be about right here. I should have made this a little bigger, and it goes up like that. And so that is what our graph looks like. Okay, let's move into polynomials that aren't quadratic, and we are going to do some of the same things. Okay, here we go. 3i. For each polynomial f of x, determine the end behavior, find all real zeros and their multiplicities, and use all this information to do a graph. Okay, so here, the first one that we have, we're going to go ahead and factor it. It's always a good thing to factor it. Now, we have a negative 1 right here. That's something that we're going to keep in mind. Okay, so we've got a negative 1. The other thing is our highest exponent here is 6. So we have a negative leading coefficient, and we have an even exponent. So the end behavior of our graph is going to go down, and they're both going in the same direction. Okay, so it's going to look something like this. We don't know exactly, but it's going to look something like this. Now, one of the things that I do is anytime my leading coefficient is negative, when I start to factor, I go ahead and factor that out. That negative comes out because I've got a GCF. So I'm going to pull a negative out of that. And then I've also got an x to the 4th in both of these. When I do that, when I take out a negative x to the 4th, I'm then left with x squared minus 9. And that's a difference of perfect squares. So then once I factor my difference of perfect squares, I'm left with x plus 3 and x minus 3. So we've got the end behavior. If I've got negative x to the 4th as one of my factors, I'm going to set that equal to 0. Then I have x plus 3 equals 0 and x minus 3 equals 0. So x equals 0, and x equals 0 has a multiplicity of 4. Okay? 0 occurs 4 times. A multiplicity of 4. That's going to be important when we do our graph. X plus 3 equals 0. that means x equals -3, x minus 3 equals 0. That means x equals +3. Now, -3 and +3, they just have a multiplicity of 1. It's this x equals 0 with a multiplicity of 4 that we really need to focus on, okay? So I'm going to erase some of this over here. I'm going to draw my graph. I know I don't draw straight lines, so hopefully you do okay with that. So I have 1, 2, 3, 4, -1, -2, -3, -4. Okay, so we have here at 0, we have a multiplicity of 4 there. That's our x-intercept. It's also our y-intercept because we don't have a constant at the end of this. We just have -x to the 6th plus 9x to the 4th. So you can think of that as +0, and that's your y-intercept, the +0. You could also plug in 0 for all of your x's, and you would also get 0. So that's your y-intercept. Then I have -3, and then I have +3. Now, you might decide that you want to do the end behavior first. So we know our end behavior is going to go through this -3 and through this +3, and it's going to go to -infinity. So it's going to keep going like that. We also know that our 0 has a multiplicity of 4. Because it has an even multiplicity, it touches the x-axis, and then it changes direction. So because of that even multiplicity, that's what it does, okay? It may do another little behavior there because it's got a multiplicity of 4, but the thing that you really have to acknowledge is because of the even multiplicity, it hits it and it changes direction. So then from that, we can draw the rest of our graph, and it looks like that. So that is our graph of -x to the 6th plus 9x to the 4th plus 0. Okay? So now let's do the next one. So here we have x to the 3rd minus 2x squared minus 8x. So for this problem, we have an odd exponent in our leading term, and in front of that is a +1. So we can think of our leading term as +1 x to the 3rd. That behavior is going to look similar to the slope of a line. It's not like a slope of the line, but the direction is the same as the slope of the line, a positive slope of the line. Okay? Because it's odd, that means the direction is going to go in opposite directions. Because it's a positive coefficient, that means it's going to take on the end behavior of what we think about with a positive slope. Okay, so hopefully that is helpful. Now, so we have our end behavior of our graph. So we're going to go ahead and factor this to find our intercepts, our x-intercepts or our solutions. We have a GCF here of x, so I'm going to have x times x squared minus 2x minus 8. Then we need to go ahead and factor again. So for this one, I can factor this. It factors to x minus 4 and x plus 2. -4 times +2 is -8. -4 plus +2 is -2. So that's how we're able to do that. Then I do each one of these set equal to 0. So I have x equals 0, x minus 4 equals 0, and x plus 2 equals 0. Don't forget that you have to put this x. That's the solution. So you've got to set that x equal to 0 too. So my solutions are 0, +4, and -2. Okay? And all of the multiplicities here are 1. Each one of them has, they all have a multiplicity of 1. So let me go ahead and write that. All have multiplicity of 1. Okay, so that means they're all going to cross the x-axis. Okay, we're not going to have any bumping into the x-axis. They're all going to cross the x-axis. So then I have, okay, so I cross the x-axis at 0. I cross the x-axis at positive 4. And I cross the x-axis at negative 2. Okay, so when I draw this, I go in a similar direction as a positive slope of a line. I go from the bottom left to the upper right. And let's see, did we get everything? We have in behavior, all zeros and their multiplicities, and then we sketch the graph. Okay, let's do the next one. This one is already factored for us. So I actually think that's kind of good news. We have quite a few factors here, okay? So we've got negative 3x, then we have x plus 4 with a multiplicity of 2, and x minus 3 with a multiplicity of 2. So for this, we need to count how many x's that we've got. So here I've got 1x. Here I've got it squared, so that's 2. X plus 4 squared, that means I have 2 x's. X minus 3 squared means I have 2 more. So I actually have 5 factors here. So I have 5 factors. If I have 5 factors, that means I'm going to have 5 zeros. Now, some of them have multiplicities. So we have to think about what happens at those multiplicities. But I still have 5 solutions. So this is similar. The graph is going to look like what a graph x to the 5th would look like. Now, it's also negative. Do you see that negative 3 right there? So it's negative. So we have an odd exponent and a negative coefficient. So our graph is going to look like this. It's going to look similar to a negative slope. That looked a little funny right there. So let me make that a little smoother. How's that? A little bit smoother. So they're going to go in opposite directions, and they are going to carry on the same kind of direction as a negative sloped line would. Okay? That's what's happening there. Now, let's set each one of these equal to 0. So I have negative 3x equals 0. I have x plus 4 equals 0, and that has a multiplicity of 2 right there. Okay, so I have x equals negative 4. That occurs twice. So we need to think about what's going to happen to that graph at negative 4 because of that, at negative 4 because of that multiplicity of 2. And then I have x equals 3. So x equals negative 4 and x equals 3 has a multiplicity of 2. And when we have that multiplicity of an even number, that means it touches the x-axis and then changes direction. Okay, so let's look at this. So we know our end behavior of our graph. Okay, we have a 0 at 0. Okay, so that is also our y-intercept. Then I have a 0 at negative 4.